Sir, in last class we learned about axioms, sir.
Okay, we learned axioms and
So axioms are actually the truth. They are truth itself, sir. So we don't need to prove it, sir.
okay, axioms are the statements, mathematical statements, okay, which can be accepted as truth without being proved. All right.
Sir, the difference between axioms and theorem is axioms no need to be proved, sir, but theorem should be proved to be accepted as a if accepted as truth, sir.
Correct, G. The main difference is that axioms are logically, it makes sense to us directly when we hear them, and we don't need to prove them, whereas a theorem needs to be proved. Okay, a theorem needs to be proved. Can someone give me an example? Raise your hands to let me know. If you can give me an example of an axiom. Give me an example of an axiom. Yes, Riza.
Sir, linear pair is an axiom.
Just if you say linear pair, no, just tell me the full statement that would make it an axiom.
Sir, sir, if a ray, that day we discussed about the converse also, sir, for linear pair axiom.
Yes,
If a
yes,
ray
yes, tell me
stands
that.
on a line,
Mm-hmm.
sir,
Yes, go ahead, tell me.
sir, if a ray stands on a line, sir, then the two
Mhm.
adjacent angles are supplementary, sir. This is just like a logically, sir. If there is a straight line, then if a ray stands on it,
The adjacent angles are supplementary, correct, and that's a linear pair axiom. Why do I think that it's an axiom, Riza? Why do you think that naturally it is making sense? What is about this? What is the reason that it is making sense naturally? You want to go with that a little bit?
sir, we already know that the ray is on a straight line, sir, and straight
Perfect.
line is always 180 degrees, sir. So
Perfect.
those two angles will also make 180 degree. Their sum will be 180 degrees, sir.
Great, Riza. Thank you so much. The ray. Okay. Anyone else would like to give me a simpler example of mathematical statement which can be accepted without any proof? Something without geometry, something very simple. I want to go to someone else, not Riza or Human. Someone else. Just type in the chat box, maybe, if you can. Yes, MG has typed it for me. So MG tells me that, sir, 2 plus 2 is equal to 4. This was one example, and the next example is 2 plus 2 is equal to 4. All right. Now 2 plus 2 is equal to 4, or any such thing. Like I have any operation which we have learned in our childhood, very simple mathematical operations are axioms. We don't go into proofs for those things to be accepted as truths. The reason could anyone would like to like, so okay, I'll just go ahead with it. The reason would be that intuitively we know when we have two objects and we put another two objects together, the resulting number of objects is counted as 4. All right, and this is an intuitive understanding we have, something we have learned by the labeling of numbers we know from before. All right, and any other operation as well. Any other mathematical operation, a multiplication table, you don't need a proof for that. All right, and these things are also examples of axioms. Now, example of theorem, anyone from the last class? Anyone remembers examples of theorems? Please raise your hands. What other than Riza? Someone else who remembers theorem? Maybe if Abhi, Dilruba, Mansa, anyone could raise their hands. Dinesh, yeah, you're raising your hands. Unmute yourself and go ahead, Dinesh.
Sir, example for theorem is Pythagoras theorem, sir.
Okay, one example is Pythagoras theorem. Okay, what else do you know? Pythagoras theorem. We have proved this last class, Dinesh, in not last class, I mean in class 8. Do you remember the proof?
Yes, sir.
It's there in your notebook. There was a square, and then we had smaller squares and triangles being formed inside of that thing. and we called this A, B, and C, and we had done something to prove this. All right, I'm not going into the details now, but Pythagoras theorem is a clear example of something which we could not believe directly. All right, because it's a very complex statement. It had, so there was one whole. Anyone can tell me what the Pythagoras theorem states before we move ahead quickly? Raise your hands to tell me what the Pythagoras theorem states. Dilruba, yes, go ahead. Dilruba, what does the Pythagoras theorem state?
Sir, mathematical statements need to be proved, sir, to be accepted.
वो तो theorem का meaning है. मैं पूछ रहा हूँ Pythagoras theorem क्या बोलता है? What does the Pythagoras theorem state specifically? Dilruba?
Pythagoras theorem, sir.
Yes. What does it state? Do you remember? It was something about a right angle triangle. Can you tell me? Let's take.
No, sir.
Let's take this side length to be A. क्या Dilruba? Come on. Let's take this side length to be A. This side length to be B, and this hypotenuse to be C. अभी याद आया कुछ?
Sir, a square plus b square is equal to c square.
Very good Dilruba. A square plus B square is equal to C square. यहाँ पे C कौन सा side है हमेशा? C कौन सा side है हमेशा?
Hypotenuse, sir.
Hypotenuse. Okay, C is always the hypotenuse. So hypotenuse square is equal to the sum of the squares of the legs. Okay, these are called legs, or this is also called height and base. Different words, different mathematicians use. A is one leg, B is one leg, C is the hypotenuse. So sum of the squares of the hypotenuse, which is this, is equal to the square of, sorry, sum of the squares of the legs, which is this, is equal to the hypotenuse square. All right. Now this is a very complicated statement, not something we can believe directly just by hearing this. Okay, so we need to prove this, and we have done this in grade 8. Not going into that now. Maybe we'll do it once again this year. Okay,